everyone. Uh, this is the the knowledge sharing session on embedded systems. Like in this video, we will see the switch debouncing, and the using the software we will debounce the switch, and we will try to detect two states out of it. One is a short press, another one is a long press. And in this case, we are trying to use switches, push button switches, where there is a push and release. And let's start the presentation. So what happens when we press the switch? So if you press the switch, okay, like let us say if the switch is normally not pressed, unpressed, then there will be some default state. And when switch is pressed, there will be in the inside the switch there will be mechanical plate is used, like there will be spring action inside the switch before it comes to the actual pressed state. So because of the vibrations, the spring actions inside the switch of the metal contacts, there will be some variations in the voltage level before it is actually settled. Okay, in this case, before a switch is normally low, and when the switch is pressed, there is some oscillations on the output, and before it settled down with the switch pressed state, this is a high. Okay, so in order to avoid this kind of when this switch oscillates, when the switch is pressed, there will be some variations in the voltage level. Because of that, the software, when we read the switch step-in input from the software, there will be some. If there is a chance that before the switch is settled down, there can be we can detect the switch, and also this particular variation, the vibrations, it can also happen to the vibrations. Okay, and so, to solve this problem, we will use something called debouncing, where once the switch is changes the state, we check for that switch is stable for so much of time. Let us say 50 milliseconds or 100 milliseconds. It is stable for that value. Only then we take that value for processing, like a switch is pressed. Okay. So normally switch is connected using this circuit. There is a in this case I'm considering the pull-up resistor. So there's a MCU pin input will be there, and we'll be connecting the pull-up resistor, and there is a active low switch input. Switch is connected to the ground, other switch input is connected to the MCU pin. So when switch is not pressed, so it is open circuit, and normally there's a pull-up resistor is there connected, and because of this on the MCU input we will be reading the high input. Okay, so when the switch is pressed, so the pin connects to the ground, and we will be reading the 0 volts. Okay, this is how the switch works in case of pull-up resistor. So pull-up resistor, for the switch, a pull-up resistor is mandatory for the switch to work. Okay, otherwise there's a possibility that we'll be reading the higher low tri-stated output. Uh, uh, it is possible that if you don't use the pull-up resistor, then there is a chance that we read the high or low variations even though without pressing the switch. Switch press can be detected. So because of that, to get the stable state on the MCU input, we need to connect the pull-up resistor. And some MCU Arduino inputs, there is a internal pull-up resistor is there. If internal pull-up resistor is there, it is possible that we can enable the internal pull-up resistor, and we don't have to use the external pull-up resistor in that case. Okay. So yeah, this is a simple circuit, how to connect the switch to the MCU input, Arduino or any MCU input, and we'll go ahead. Software strategy to debounce. So when we read the switch input in the loop function or in the while inside the while one in the software embedded system embedded C, so switch can be detected for many number of times because normally user takes around 200 to more than 50 to what I mean is it'll take around 50 to 100 maybe up to 1 second sometimes depending upon the user. The switch input will be active for 50 milliseconds to 1 seconds. So in this case we will use the first method. If you use the first method, that is a simple switch input every fixed time for one count. That means let us say we will try read the switch input every 200 milliseconds. We take decision. and this can be considered as if that switch is high, then we can consider that as switch is pressed. And still, there is a risk of multiple switch press detection if the switch is pressed for longer time. Okay, switch pressing longer time, it means user pressing the switch for longer time in the for the MCU input. Okay, and second one is sample input every fixed time for n counts. That means in this case, I'm just taking an example where 10 millis for every 10 millisecond we sense the switch input. If it is stable for 5 counts, we can take that as a decision. Okay, so here we are basically 5 counts means here we are basically debouncing it for 50 milliseconds, because 10 milliseconds one count and 55 counts means 50 milliseconds. This approach gives the stable results in overall cases. Hi, now we will see we'll see the demo for sampling the input every fixed time. Okay, so let me open the code. So now let's see the sample switch reading code using the Arduino. I'm just taking Arduino as a platform because we are focusing on the switch, so we can see the switch part of the code. And yeah, so I have configured the button as there is a button connected to pin 2, and there is LED connected to pin 13, and I'm taking some timestamp variables. So in this case, I'm using the switch as active low. So I have configured to 0. So 0 means active low and 1 is active high. So here I have configured the button as an input, and also please note that I am using the pull-up resistor, internal pull-up resistor. So if there is an internal pull-up resistor I have enabled, then I don't have to connect the external pull-up resistor for the switch input. Okay, the description is mentioned here that if you use the internal pull-up resistor, it's not necessary to if you use external pull-up resistor, it is not necessary to use internal pull-up resistor. Since I'm using internal pull-up resistor, I have not connected the external pull-up resistor here. So LED as output, and I'm using the serial port for printing the debug messages. So this is a sample code where just reading the switch input, and if the switch input is active, switch's active state is low, switch is pressed. So I'm pressing the switch pressed message with the index, like how many number of times it has detected the switch pressed state. Uh, and for every 200 milliseconds, I'm just toggling the LED. So this is just a debug indication that software is running. That LED is toggled. LED is just toggled every 200 milliseconds continuously, and also of course it reads the inputs, and if it's pressed, it's going to print the message. Let me upload this code. I'm going to clear. You can see the watch the serial monitor output. So I'm going to expand it a little bit. I'm going to press the reset button. I got the switch jitter test, this initial message what I mentioned. That is, I press the switch once, short press. I just pressed and released the switch, and you can see that the way, since this code is running inside the while one, it is able to detect the switch for so many number of cycles. You can see up to 0 to 8, total 9 cycles. It is able to detect switch press. It is able to do it so many number of times within the within this as long within the period that switch was pressed. Software is able to run it for 9 times. So the purpose of using the switch here is once the switch presses, we have to indicate the indication the switch is pressed. Okay, that's the expectation. But here we see that it is able to print so many number of times, and we don't. This is unexpected behavior. This we are going to solve it as the initial step using the method one. I'm going to move this code to the 200 millisecond task. Bandit 200 millisecond task is here. Okay, so this is there's a cyclic task, cyclic. This particular part of the code, which is there's a based on the timestamp. So if there's a millis, I'm taking a reference for the time, and if the time is more than greater than or equal to 200 milliseconds, I'm going to re-update the timestamp for the next iteration, and I'm going just toggling the LED, and after that I'm just reading the switch and doing the same operation. This I'm doing it every once in every 200 milliseconds. Do every 200 milliseconds once. Let me upload this code now. Okay, uploading is finished. Let me clear the screen and do the reset once. I did the reset. Now I'm just reading the switch same input without any debouncing, and I'm doing it at the rate of once every 200 milliseconds. Okay, so let me press the switch. Switch is pressed. I got one message. Second time I'm going to press. Yes, second time I got. Third time I didn't get it. You have to press a little longer sometimes. So as you can see here, the if you press the switch once, we get the switch is pressed. Okay. Second time we press, I get the switch is pressed once. You can see there is a repetition here. This is our repetition. Like ideally, we should get only zero instance, and this particular since I pressed a little longer, I got more number of times because here I'm doing it every 20 milliseconds. If I press the switch for around 600 milliseconds, I get three times this is going to run, and again still we will have the same problem. That switch is detected for the more number of times. This solves some problems sometimes, but this is not the maybe the efficient way, or this is not the proper debouncing algorithm. So now we will see the second method. Like this is the demo of the first method what we are seeing now. And if we go to the other method, like where we are I'm going to open the presentation. Okay, this we are right now we have seen the switch input fixed for every one count, that is sample every 200 milliseconds, and this is where I've seen the demo now. Then I'm going to show the demo for the switch input every fixed time for any counts. That means sample every 10 milliseconds for 5 counts and take decision based on that. Okay. So under this method, I'm planning to detect the switch for using two states, two presses. One is a short press, another one is a long press. Okay. The strategy for short press is switch is pressed and released. Total press time is between 50 milliseconds to 1000 milliseconds. That means 5 counts to 100 counts in the 10 millisecond cyclic task. Okay. And long press detection strategy. This means like if the switch is pressed and held for more than 1.5 seconds continuously, then we declare that it is a long press. Okay, this is a strategy to detect the short press and the long press. There is a difference. Short press is we just press and release, and we detect it as a short press. Okay, long press is we pressed and held the switch for longer than 1.5 seconds. Okay, this comes under the long press strategy. Okay, we are going to detect two states using the single switch in the software. Let me open the software. Yeah, so this is our software debounce module. So here I have taken the same example. Of course, I have created a separate switch module here. You can see I have created one separate .cpp file. So this is basically this is where I have defined the two functions. One is to clear the switch. This is the global variable which tells which has the states like small tap or long tap is pressed or no tap is pressed. So if normally this function is called every 10 millisecond task. Okay, and here we have here I'm just using the three static variables. One is to hold the old state, another one is to hold the number of counts, debounced counts in that state, and the switch flag. Okay, so here we are just reading the switch input on the digital read directly input. I'm just reading to this state, And based on this, if the old switch state is changed from the old state, and if the switch is active, in this case, this active means active low here. Here, there you can see the macro active low. So if that means switch is active low, that means switch is pressed. Okay. Otherwise, switch is not pressed. Switch is released. Okay. In case of the switch is pressed, I'm going to increment the debounce counter. Okay. Debounce counter I'm incrementing, and if the debounce counter is, that is a 50 milliseconds to, let me upload this code. Maybe it has to compile to load the macro values properly. Yes, it has loaded. Let me see that this is for the short press, which is pressed and released. Short press, and time is between debug count is between the min and max. You can see here. There's a macros here defined. 5 to 100, like 50 milliseconds to 1000 milliseconds. And if switch is pressed and released, you can see lag is 0. Pressed and released, and there's a time is between this range. We classify that as a small tap is pressed. Okay. If the switch is pressed, okay, and count switches that this is switch flag is 1. That means the switch is pressed and held like that high, and count is more than 115, 150. Just a minute, what is it? 150. Yeah, 1.5 seconds in 10 millisecond task, and then we declare that state as a long press. Okay, so this is going to count, and this is this returns the old state, and this will be repeated every. This task is called every 10 millisecond continuously, and finally we get the debound state in the this particular variable switch one. Switch one is basically global variable. If you see the hex file, header file, switch one is here and is an external global variable, and it has three states: no tap, small tap, or long tap. And we call these variables, these functions. Switch db cyclic function is called every 10 milliseconds, and in this variable we get the output after reading the processing the switch one, small tap or long tap. In the application software, we have to call this function to clear that state. Okay, world state. Let me go to the main function. So if you these are my main task where I'm importing these two switch modules. Switch header is imported here, and there's the same switch and LED, and there's a timestamps. And here I have called this is a global variable which I have defined it in the switch module. I'm seeing if it is small tap or long tap. Small tap, I print switch small tap. If long tap is detected, I'm going to press switch long tap is detected. And at the end of it processing, I'm going to clear this switch one variable through the switch debounce clear. Okay, clear the states after the usage of the variable states. Okay, and in the okay, this is the important one. The every 10 milliseconds, I'm going to call the switch debounce task. Okay, switch debounce task is defined in the switch module, which will actually do the reading and debouncing, and based on the count, it's going to evaluate, and that is done in the switch debounce task, and every 200 milliseconds in the other schedule on the cyclic task, other cycle time where I'm toggling the LED. Okay, so LED is just for debugging indication that software is running, and this is the actual function which does the debouncing of the switch and updates the switch one variable. And here in the switch one variable, I'm just reading the if it is a small tap is detected or long tap is detected, then I'm going to print the message, or I can do any operations whatever I want. And let me see its behavior. I have uploaded the software. I'm going to reset it. Switch debounce test. I got the message. I'm going to do the short press. Short press is done. Every time I press the switch without any problem, I get the small tap is detected. Small tap. Small tap is basically short press. Just press and release. Okay. Small tap, small tap, small tap. Let us say I want to do the other operation with trigger the other operation using the long press. Okay. Let me press the switch and hold it for some time. I pressed it. That is after some time I got the message switch long tap. Okay, so first time every small press and release I detect it as the small tap. When the switch is pressed for the long time, I detect it as a long tap. So here, based on the switch one, long small tap, we can do some operation. Yeah, say the same switch, press and release, press and held for long time. I do the other operation. So this is how the switch driver is switch module is implemented. And okay, here these are you can see that these two are the APIs from this module. And see, I have since I'm using it this file in the with the Arduino, I have just renamed this file as a switch.cpp. If you're using in embedded C any other IDE, you can rename this file as a switch.c, okay, instead of cpp. Okay, so yeah, and of course you have to map the respective input to this particular signal, and then this algorithm should work as expected. Okay. Yeah, so this is about the switch module. Okay, so this will come to the end of the session where we are able to detect the switch as a short press or the long press, short press, press and release. So that is detected as a short press. Press switch press and held for longer than 1.5 seconds. That will be detected as a long press. So yeah, this is the expected output we are seeing on the serial monitor where we are printing the debug messages like here, switch small tap and long tap. At the end of it, we know like usage of this signal, we have to call this db clear, which will clear this variable and it will reload the new values when the new switch is pressed again. Okay, this is mandatory step. Okay, this is our part of the application code, and this is the driver function which will debounce the switch input. Yeah, see in this case I've taken only switch one as a reference, and you can copy paste and rename the variables, and you can use it for any number of switches like switch one, switch two, switch three, whatever number of inputs you can. These are debouncing the algorithm, and you can copy paste and rename it for other switches also. It should work as expected. Thank you. This is the end of the session, and so this is about the switches, switch debouncing strategy. And here we have seen the driver for debouncing and switch driver for detecting the short press and the long press using the single driver. Thank you. Thank you very much.